So in the previous video we have seen what is the water demand, what is the source, collection, and what is the meaning of water treatment plant. Now for the design of this water treatment plant, so in this water treatment plant there are various components that we will be seeing. For the designing of that components will require certain quantity. So the main quantity will be, or the most important is called as Q, capital Q, and that capital Q is nothing but the discharge. So what is discharge first? So this discharge Q, the formula for this is volume of water or volume divided by time. So the unit for volume, if we take, it is meter cube, and for time it is second. So the SI unit for a discharge, SI unit of discharge is meter cube per second. Now if we take a pipe and let's say some water is flowing through this. So to find out what is the discharge, what we have to do is we have to measure a particular amount of time. In that time, what is the volume of water that has passed through this pipe? And if we take the ratio of volume of water passed divided by the time in particular time, so we will get the value of discharge. Now in this water supply engineering, this Q is the main parameter. Now what are the things in which or on which this Q depends? So this Q is a function of, that is the discharge depends upon what is the population. Population of what? Population of that city or town. It also depends on the water demand. What is the demand of water in that particular area? And one more thing, that is what is the design period. So this design period means what is the life of the water treatment plant. So these are the three parameters on which the discharge depends. Now whatever is the size of treatment unit, this depends on discharge. As we have seen in the previous video only, this water treatment plant, or we can say the design of water treatment plant, mainly depends on the Q value. Hence the Q value is very important. Now we will see how to find out the Q value for designing this treatment unit. So this discharge Q, it is equal to population at the end of design period. Population at the end of design period multiplied by per capita water demand. Per capita water demand. So this is a very important formula and you should note this. This is the first formula from water supply engineering. So how to calculate the discharge? We have to calculate discharge by the product of population at the end of design period and per capita water demand. So this per capita water demand, what is the meaning of this? So let's take your example. What is the water, or what is the amount of water that is required by you in the total one day? So in one day, how much water you are consuming, that is nothing but the per capita demand. We'll see in the next video in detail about this. One thing you should note, that this per capita demand is constant. Per capita water demand is constant. because we will be taking the average value, hence that value will be a constant for a particular area. Now what do we mean by population at the end of design period? Now this water treatment plant, which we have discussed in the previous video, this water treatment plant is a big structure, so it will require some heavy investment. So obviously we will be designing it for some, it will be designed for some good years, or we can say there should be some design year. In general, for water treatment plants, 15 years is the design period. That is, up to 15 years it should work properly, and after that we have to build a new one, or we have to do the proper maintenance. So let's take an example that in 2020, it has it is started that we have started building the water treatment plant and it is completed now. So water treatment plant is built now. Now which population we have to take? Do we have to take the population of water treatment plant of today, or we have to take it after 15 years? That is, it is 2020 plus 15, it is 2035. Which population we should take, at this point or at this point? So we have to take the population after 15 years. If we take the population of current year, then what will happen? Slowly the population will increase, and when the population will increase, the water treatment plant will not be able to meet the requirements of water. Let's say the population right now is 1000. After 15 years, definitely it will be more than 1000. Let's say it will be 6000. So we have to design the water treatment plant for 6000 population, so that it should work properly, it should meet all the requirements up to the population is 6000. Once it is 6000, we can increase the capacity. So that is the overall procedure. So this first thing in the formula, that is population at the end of design periods, means this population we have to take 6000, not 1000. And this per capita water demand means what is the amount of water that an individual requires in particular day. Now in the next video we'll see this in detail. So you just learn this formula and we'll move to the next video.